I'm David Illig. I'm an electronics engineer at NOC AD at Pax River, Maryland. And I'll be talking to you about digital signal processing for hybrid LiDAR radar. So before we get into it, I feel like I have to explain what hybrid LiDAR radar is. So we're interested, it's great to follow up David's talk. So we're interested in sending out waveforms, getting returns, figuring out where things are. And we use radar a lot above water, in the air, but you try to send radar through water. Water absorbs the radar signal, the radar energy. So you can't use radar in water for operationally significant ranges. But there's all this great work that the radar community's done in processing and looking at different challenges like tuning the waveforms, as was shown in the previous talk. So what we came up with instead was we'll send a laser in the water and we'll apply a radar-like modulation to the laser. So essentially we turn the laser on and off very quickly with a radar-like pattern. Our detector recovers the pattern. Now we can do radar signal processing in water using this optical carrier. So next I'll talk a little bit about the big picture, why the Navy cares, what we're doing. So the lab I'm in is doing communications, imaging, and ranging work with these techniques. My main focus has been on the ranging applications. So I'm looking to improve the optical detection and identification of underwater objects, essentially trying to answer the question, how far away can we see something in a certain water condition? And there's a variety of Navy applications, some of which are listed here, which range from things as sophisticated as ASW to things still of interest but less sophisticated like bottom mapping. And as the cartoons on the side show, these sensors, depending on the mission, the application, could be mounted on a variety of different platforms, underwater vehicles, surface vessels, helicopters, fixed-wing aircraft, all depends on what you're trying to do. You can use the technology for many applications. So I've got just a couple photos here showing in our tank what these conditions look like, in one of our tanks, I should say. At the top is a high visibility condition. You can see this boxed back there. There's a rectangular target in the back of our tank. We can see it with the naked eye. We see the nice narrow laser beam illuminating it. Things become more challenging again in these murkier conditions. So we simulated a harbor condition. I don't think we can make it out with the resolution here, but there's a target there. You can see it with your naked eye in the high def version of the image. But you see that, again, the whole thing is illuminated now due to this forward scatter problem. Then finally, in the bottom, the target's further downrange. We can no longer see it with the naked eye. We hope our sensor can still see it. All we can see with the naked eye is this glow due to the backscatter. So what I'm doing in my work is trying to look at signal processing techniques to separate these weak targets from the scattered light. I want to talk a little bit about what I'm doing right now, which is I'm using a technique called blind signal separation. So this comes originally from the speech processing community. There's this problem called the cocktail party problem, where imagine you're at a party, you're talking to somebody, people around you are talking, you want to hear the voice of the person you're talking with. Well, it turns out our brain can do that naturally, easily. You don't even think about that, it just happens. So these speech processing people have tried to come up with ways with sensors and mathematics to mimic that ability. And that's this blind signal separation family of techniques. For us, what we're trying to hear, if you will, is the target. That's the voice from that cocktail party problem. And the scatter is all the crowd noise that we want to get rid of. So by implementing these techniques, we've actually been able to pull out weak targets from strong backscatter scenarios, which is, again, what that cartoon at the top is showing.